Hello everyone, and welcome to This Is Your Life Cycle. I'm your host Sel, and tonight we will be celebrating one of our most infamous, intelligent, but widely misunderstood viruses. Tonight we'll be appreciating the life cycle of HIV.
HIV has claimed the lives of nearly 39 million people globally. Malicious and destructive, he has started epidemics, created hate and controversial policies. Baffling scientists, his methods are still incurable and he only enters your body for one reason: death.
So, now all that's left is to go find it. Let's go. Oh, HIV. Wow. Surprise, mate?
Shit.
How you doing?
Oh, it's been good, really good, man.
Okay, so let me just introduce myself. I'm Sel. I'm the host of This Is Your Life Cycle. And we just want to take some time out tonight to celebrate all that you've done for the virus in the world.
Wow, I'm excited. I can't, I'm speechless.
Yeah, it's alright, mate. Let's just get you to the studio and get started. Hello everyone and welcome to This Is Your Life Cycle. Now I want everyone to give a big round of applause for our main guest tonight, HIV. How you doing, mate? Welcome to It's nice to have you. Take a seat, man. Get comfortable. It's going to be a long night. We're going to go through every stage of your life cycle today, and before we do that, I just want to take it all the way back to where it all began. Are you ready, mate?
More than ever, man.
Alright, let's do this. This is your life cycle.
HIV. You were traced to originate from the large hustle and bustle of Kinshasa. It was here that you decided to make the jump from chimpanzees and into the human species. Why?
Well, monkey blood, you know, it's doesn't taste nice, and then when humans start handling monkey meat, you know, I find the perfect opportunity to jump. And let me tell you, human blood's a whole new world.
Well, I can imagine, man, but I want to throw back to the 1980s right now. Do you remember the 1980s?
God.
Yes, it's your entry to your very first white blood cell, and we're going to be showing the audience just what you went through.
God, no.
Hi Emily, this is Dr. Smith, and I'm gonna do the blood transfusion for you today, so don't be scared.
Ow, that hurts.
So that seemed like just your ordinary blood transfusion, but I think HIV was being pretty sneaky there. Let's take a closer look.
Hi, I'm just
Hi.
looking for a place to stay tonight.
I have plenty of room. I'll make food. Come inside.
So you look like you were really up to something there, man. What was going on?
Oh, well, it's just a blood transfusion, you know.
Okay.
It's a common way of entering. However, you know, there are other methods, which sometimes my cousins, you know, some of them prefer going into a body through sexual contact.
Okay.
Hang on, everyone has urges, mate. Everyone has urges.
Yep.
There's also when people share needles, or when when the needles aren't sterilized properly,
Okay.
and through mother to child transmission.
Okay. So I'm getting you're a really dirty guy.
Oh, come on, mate. I have feelings too.
Just kidding. So what do you do? So I'm getting it straight. Like you're actually in the body now, and don't you have to go into the cell now? Is that how it works?
Yes, after that I have to infect my host cells. I have to find a new home. In this case, it's usually CD4 T cells or macrophages.
Okay. Well, let's take a closer look at that.
As you can see there, I am at number 1, outside my new home. Right now, I'm about to fuse the host cell membrane.
Okay.
Before I fuse, I'm surrounded by an envelope which contains glycoprotein spikes, or in this case, GP120. These spikes interact and attach with receptors and co-receptors, CCR5 or CXCR4, on the cell surface, which then changes the shapes of the spike, pulling my membrane and the cell membrane together.
Okay. So now you've actually entered the white blood cell. What happens next?
Oh, well, this is a pretty interesting part.
Oh wow. We actually have some very, very big news. A very special guest has come all the way to join us here tonight. I'm sure you're very familiar with her. Might be a little awkward, but hopefully not too much. But it's actually your very first white blood cell. Please everyone, big round of applause for white blood cell. Thank you so much for joining us here. White blood cell? White blood cell.
Hi.
Hi, thank you so much for joining us tonight. It's actually a really big pleasure for us. And you come all this way to celebrate HIV's
I only
life.
came here for one reason.
I came in like a wrecking ball.
I gave you a home and you used me.
I never hit so hard.
We'll be right back. You came in.
Yeah, this always happens.
Okay, cut.
Go.
Hello everyone and welcome back to This Is Your Life Cycle. Tonight we have a very special guest, HIV. Things did get a little heated before the break and we do apologise for that, but things have settled down. You alright now, mate?
Yeah, I know. Like, what can you do, man?
Yeah, white blood cells, man. They never understand. Anyway, we're up to one of my most favourite stages in your life cycle, replication. But I heard it's really complicated.
Yeah, I mean, it is, but this is one of the stages I'm most proud of. The first step to replication is reverse transcription, as seen in part 3 of this image. This is where an enzyme called reverse transcriptase initiates the formation of one double-stranded molecule of my genetic material into DNA by copying the sequence of my RNA strands. Next, I have to integrate into the nucleus. This is done through the help of my friend integrase, who is an enzyme that incorporates my DNA into the cell's DNA. I am now known as a pro-virus, and have successfully occupied the cell forever. Now, the really sneaky and evil bit is where I get into the host cell's own machinery that is normally used for the transcription of human genes to create new viral molecules. These leave the nucleus and undergo translation as they now contain my genetic code. As seen in number 5, this results in the creation of new viral proteins. Finally, I assemble all my viral proteins, enzymes, genetic material together and move to the cell's outer membrane. Here I create a bud, which can then leave the cell's membrane by budding off from the host cell. And my babies are now loose to have some fun.
Wow, you're really sneaky, man, but I love it. But now to the most interesting part of your entire life cycle, the latency phase. It really does set you apart from all the other crappy viruses. It is really a big display of your genius. Can you explain to everyone how it actually works?
Yeah, no worries. So, after I infect a host, I like to multiply really fast. I like to have some fun, you know.
This guy. I can tell after tonight with your incident white blood cell, you're a cheeky guy, this guy.
But, unfortunately, the immune system's pretty good. I have to give it to them, you know. He catches all my children, he gets rid of them. It's pretty unfortunate. However, I'd have to say, I'm on top of this. He doesn't catch all of them, and I'm still able to multiply slowly.
Okay, but I do have a question for you, but so you're multiplying slowly now, but what do you actually do to the host?
So, initially the host feels a little sick, a bit of flu-like symptoms, but then after that they're fine. But they don't know I'm still replicating. I'm still attacking that immune system. And 10 years later down the track, when their immune system is weakened, eventually I can let my buddy the common cold come in and finish the job.
So that's where you strike.
Yeah.
Okay, so that officially brings your life cycle to a close here, HIV. It's been an absolute pleasure having you though, mate. And we want everyone to stand up and give a big round of applause to HIV for being such a great sport. Thank you, man.
Thanks for having me, man.
No worries, man. What are your plans now?
Well, then I was just about to infect a third victim when you called me.
Oh,
so I'm going to rush off.
Doing? Okay, bro. How about we take you back and you can do whatever dirty thing you were doing.
Excellent.
Right?
Farewell, everyone.
Farewell.
It's been a long day without you, my friend.